guys, in this video we are going to learn three sorting techniques: bubble sort, selection sort and insertion sort. I want to tell you that all these three are seemingly similar, but they are not. So you be thorough with this and don't get confused about what sorting does what. So let us start with the bubble sort. Bubble sort is one of the easiest sorting algorithms. It's the simplest sorting algorithm, and it repeatedly compares and swaps the adjacent elements if in wrong order. So in this we are considering it to arrange in ascending order. So what bubble sort does, let's see with this example. In the first pass, that's the first iteration, it compares these two adjacent elements, and since they are in correct order it does nothing, so it gives the same order. And then it compares these two, and since you can see 11 is greater than 2, it swaps these elements, so this becomes the order. And then it compares these two elements, and again 11 is greater than 3, so it swaps these two elements, and again you can see they are not in order, so it swaps again. So the first pass is completed, and you can see in the first part at the end you get the highest element. The highest element comes to the last at the end of the first pass. So you can guess what happens in the second pass is these two are compared, they're swapped, these two are swapped, then these two are not swapped, these two are also swapped, and then it's done. So you can see by the end of the second pass, the second highest element comes to the last. And in this example, for bubble sort to stop the iteration, the algorithm doesn't know if it is sorted or not. So the algorithm needs one whole pass without any swaps to know that it is sorted. So in the third pass, as it compares elements, it sees that there's no swapping happening, so it understands that the sorting is done. So if you consider the time complexities, the best case it is of order n, and for the worst case it is of order n square. The best case occurs when it's already sorted, and worst case occurs when they're in reverse order. It's in descending order and you want to convert it into ascending order. And the space complexity is order of 1 because you need a constant space. And what you mean by in place and stable algorithm is, and that is about the complexities, and the space complexity is of order 1. And what about in place and stable? It's not really important, but I have the definition, so I'll just read out for you. An in place sorting algorithm uses a constant extra space for producing the output, that is for modifying the given array. It sorts the lists only modifying the order of the elements within the list. That means it is said to be in place. This is an in place algorithm because it swaps and it modifies the places of the array of the elements only inside the list. It doesn't actually need any extra space outside the list. So it is an in place algorithm. And a stable algorithm is that if two objects with equal keys appear in the same order in sorted output as they appear in the input array to be sorted. That is a stable algorithm. I don't think it's really important. It's okay if you just could know the definition. And here's the algorithm. They generally ask algorithm, so it's you just understand it line by line, then you will memorize it by yourself.